Hello, I'm doing problem number 11 from the physics book. So what it is, it's about a metal ball that's swinging around this metal pole vertically, and it has two cords attached to it, 2 meters long both, and the entire length of this metal pole between the two cords is 3 meters. So over here, I've listed the different givens. So the speed is 6 meters per second, and it's a constant speed. The mass of this ball is 4 kilograms. And what we're looking for is TU, which I labeled for T upper, and the tension below. So this is the part A and this is the part B. So let's draw our free body diagram first. So we're going to be having a tension up here, so I'm going to call it tension upper, and a tension down here, I'm going to call it tension below. And these are because there are two different cords attached to this metal pole. Then this is going to have a weight, so that's mg. And over here I labeled my axes, so we're going to be going towards the center. It's going to be the positive x, and this is going to be positive y. Like up here's positive y, negative y, positive x, negative x. Okay, so here, let's figure out a little bit of more about the dimensions. Now that we have our free body diagram with the two tensions and that weight going downwards. So since this is an isosceles triangle with 2 meters, 2 meters, and 3 meters, what we can do is we can split it into half into two equal right triangles. So we see that this is 3 meters, this entire part, so we make it 1 1/2 and 1 1/2. And if we use the Pythagorean theorem, we can see that this radius is 1.322 meters. Okay. Next, we want to figure out the angle of this so we can figure out the different components of our tensions. So since these are two identical triangles, we know that these two angles are the same, and we're going to call it theta. So over here, let's figure out what theta is. So let's just use sine theta is equal to opposite, which is 1 1/2 meters over hypotenuse, which is 2, 5 meters over 2 meters. The meters cancel out. So our theta is equal to inverse sine 5 over 2. So theta is equal to 48.4904 degrees. So next what we're going to do is we're going to do our sum of all forces in the x, then later our sum of all forces in the y, and that will help us figure out tension upper and tension below. So first, let's look a little bit more closely at what's in the x direction. So if we do sum of all forces in the x direction, we have the different components of our T upper. So you see that over here, we're going to be having T upper sine theta, and that's going to be the y direction. And then we're going to have T upper cosine theta in the x direction. Then down here for our T below, we're going to have T below sine theta in the negative y direction, and T below cosine theta in that x direction. So we can see that both of them are in the positive direction, so we can say T upper cosine theta plus T below cosine theta is equal to NAC, and we know that centripetal acceleration is v squared over r. So we can factor this to make it a little bit easier for us to read. So we can add that T upper and T below times cosine theta, because these are the same angle. It's equal to n times v squared over r. Then we do T upper plus T below is equal to mv squared over r cosine theta. So now our mass is 4 kilograms, our velocity is 6 kilograms, and we would square that. Our radius from our Pythagorean theorem is 1.322 meters, and our theta is 48.49 degrees. So when we add these two together, we get the two tensions added together are equal to 164.36 newtons. Okay, now we're going to be moving over to the y direction. Okay, so let's sum our forces in the y direction. So, as we saw earlier, we had the t upper sine theta in the positive direction, t below sine theta in the negative, and mg in the negative. Okay, so it's going to be t upper sine theta minus t below sine theta minus mg is equal to ma centripetal. But here, let's stop a minute and look at and think about that diagram. It's moving around in a circle. It's not moving up and down. So our centripetal acceleration in the y direction is equal to 0. So we can factor this out again. T upper minus t below times sine theta. Then we're going to move over mg is equal to mg. Then t upper minus t below is equal to mg divided by sine theta. And our sine theta, as we did over here, is 1.5 divided by 2. Our mass is 4, and our g is 9.8 meters per second squared. So we get that t upper minus t below is equal to 52.26 newtons. So now we have t upper minus t below and t upper plus t below. So if we add these two expressions together, just screwing this over, t upper plus t below is equal to 164.36 newtons. So 2t uppers is equal to 216.6 newtons. So T upper is equal to 108.31 newtons. So this answers part A. So now if we just put T upper into this expression, so then I'm going to move up here. So T upper plus T below is equal to 164.36 newtons. T below is equal to 164.36 newtons minus, and I'm subtracting 108.31. So you get that T below is equal to 56.1 newtons. And that is part B of the problem. Thank you very much.